Hey everyone, it's Josh with ES Automation. Today we're making another video about collaborative robotics. What you see here is a collaborative robot workstation that will be implemented in a lab environment. Our focus is on robotic workstations as well as complete robotic work cells. And today's video is not so much about the hardware of things. We've covered that in past videos. Today's focus is on the software side of things and how we can drive a system like this. TM-Omron robots are driven and programmed with a user interface and a program called TM-Flow. And essentially what you do is you connect blocks together that are different functions. That's why they're called function blocks. And the robot will step through and complete that program. As you noticed already, I'm using a Windows keyboard and a tab, and I'm switching over to our dedicated purpose user interface. So what you see here is a user interface we have developed, an application we have developed in Windows. So the robot and the whole system is driven via Windows 10 application. This system here is a representation of this particular work environment. So it has a placement location and multiple pick locations. And the robot is now driven through this user interface without the need for TM-Flow or use TM-Flow. It'll run in the background. So I can click on different placement locations, just like you would in any other Windows program. And here, for example, I can say start picking product here, and I just say pick and place, and the robot will start its motion, scan through. In this case, there's no product to pick, but it still looks for a product. A nice thing is we have a dynamic response from the robot. As you see, our user interface dynamically responds to each and every step the robot takes. I'm going to abort this task because we didn't have product in the system. And what you see here is that with every single step the robot takes, we also have feedback from the robot with a timestamp, and for example, that in this case, no battery was found. So how does this bring value to a customer's table? First of all, it actually represents the actual environment this robot goes into. So any dedicated purpose user interface that we develop actually shows representation of the actual application and the product this system would go into. And in addition to, we get not only timestamps and feedback from the robot for every process step as you see it here, we also record that data. And especially with Industry 4.0 environments, where a system is not only a source of a product anymore, but also a source of data, we collect that data of each process step, store it, and make it available on that Windows computer for further use. So at the end of the day, you can have an Excel sheet, for example, or a comma delimited file that stores all that data that you can take down from the system with a USB stick, or if you wanted to, connect it to a network and retrieve it from a hot folder. What this system specifically also does is it was developed to be run by a remote host. So this user interface can be seen as a local host used by an operator essentially. But in the semiconductor environment and more also in the medical space, there's a specific interface called SexGem. And this system can actually be switched and driven through a SexGem interface. Everything that you see here is underneath programmed to also accept commands and send messages back to a SexGem host. Yeah, and that really sums it up. I hope you like what you saw. If you need a system with a dedicated purpose Windows interface and you also would like to have that data from that system, please reach out to us. We can definitely help you put together a nice collaborative robotic system for you. Thanks for watching, and please visit our website at www.eisautomation.com. Until next time, thank you. Bye-bye.